Assalamualaikum and hi everyone. So I make this special video for you to understand the experiment 3, which is air pressure control system. I did realize that if you just watch another video, you might have a lot of confusion. So I make this video special for you to understand this experiment. I really hope that you can watch till the end. Okay, so this experiment have objective to study the response of gas pressure control in two capacity or one capacity. But here I just explain for you for the one capacity because both of it is the same. Okay, so I really hope that you already watched this video, part 1, whereby I explain in general about the apparatus and how the system works. If you don't watch this yet, I would advise you to watch this first. Okay, so as been explained in the video part 1, this is all the introduction to the apparatus. I will not go in detail this one. Okay, you can go this one in detail. At the same time, you can watch another video, part 1. Okay, same. In terms of control system and instrumentation, I did explain to you in the video, but here we explain again. We have here PT91 gauge pressure transmitter. You can see in this diagram. It's used to measure air pressure in tank T91. We also have here a valve, pressure control valve, air to close in this green color. This pressure control valve is regulated by PIC91 or PID controller. We also have pneumatic positioner. Okay, it's also here. We also have current to air converter or known as transducer, this box, and we also have a solenoid valve. We have PCV92. I did show it in the video. It is a pneumatic control valve, air to close. It is used to protect the system from overpressure. It will turn on automatically when the high pressure occurs. We also have a pressure gauge, temperature gauge, and FI92, which is a flow meter. You will see this flow meter in the first procedure. We also have pressure relief valve and a solenoid valve. And the most important here, we have a PID controller known as pressure indicator controller 91. From the screen, this controller have the value of PV, which is the value of process variable, or currently the value of control variable inside T91. It also shows the value of SV, which is set value or set point, the value of manipulated variable MV. Here is the percent of PCV91 closing, since this valve is air to close. MV 100% means this valve is fully shut. MV 100% means this valve is fully shut. MV equal to 0% means the valve is fully open. Since this is air to close valve, the percentage is the percentage of closing. Okay. So this controller also have two mode, which is auto mode. You have to press this button if you want to turn it into auto mode, or press this button to turn it into manual mode. The difference between auto mode and manual mode will be discussed later. can hear, this is a alarm. Okay, the alarm for pressure, alarm different. Here we have piping and instrumentation diagram for this air pressure control system with T91 and T92. You can see the inlet of process air is here, and you can see the control valve at the outlet from the tank. And if we are using one capacity, which is only T91, the air supply will goes into this tank and goes up and flowing through this control valve and vent out. At the same time, we have another route here whereby the PCV92 is here for the overpressure limit, that it will turn on automatically when the gas is overpressure inside this tank. This is the safety feature of this system. Moving on to the first procedure, I did explain in the video. This is AR91, okay, is set between 26 to 28 psi. Okay, that is procedure number 1 by adjusting the manual valve MV91 so that the F92, which is here, so that this F92 will shows a reading of 30 Newton meter cube per hour. This one. Okay. Note that in this first procedure, you have to ensure the condition of PCV91 is fully open, but this is not stated in the procedure. I was adding that so that you can understand. In order for the gas to flow through this flow meter, the PCV91 should be fully open, because the location of this flow meter is at the outlet of the tank. Same goes with the location of PCV91. The next procedure is for you to check the condition of pressure control valve. With the condition of pressure control valve fully shut, meaning to say the value of MV1 is 100%, the parameter FV1 should be within this range of value, 22 to 27. This procedure is for us to check whether the air supply to the system, the process air supply to the system is sufficient or not. Okay, and in this case, you have to ensure that your MV1 is 100%, and in order to manipulate this MV value, this controller should be in a manual mode. You have to press this button. Once you get this value, you can proceed to the next procedure. If you don't get this value, you have to go back to procedure number 1. For the next procedure, in the condition of pressure control valve PCV91 is fully open, meaning to say the value of MV1 equal to 0, again you have to check the value of PV. In this control valve condition, PV1 should be less than 5 to 6 psi. Okay, if you don't get this value, again you have to go to procedure number 1 and adjust the MV91 so that the FI92 will show the value of as stated in procedure number 1. Moving on to the next procedure, we have to make sure that this valve is really connected to our controller. In order to check, we have to make some tests. For example, here, when we change the value of MV1 equal to 100%, we have to check physically the condition of control valve, whereby the scale indicator, which is in this red board, I'm sorry that I forgot to zoom in. The value of valve stem is exactly the same. For example, if you have 100% MV, the valve stem should be on this level. Whereas if you have 0% of MV, the valve stem should be down here. This symbol showing it is open, and this symbol showing a close. We have this system using air to close control valve, as compared to the level control system, it's using air to open, whereby you can see the symbol is in opposite direction. Next, you have to check in the condition of MV equal to negative 6.3%, meaning to say the valve is fully open. This is the minimum value of control valve, and the condition of valve stem should be here. Before you start your experiment, you have to make sure the connection of the flow is in a correct way, whereby there are a valve should be closed and there are a valve should be open. You can see in the video.
Outlet from tank T91 goes down as it's bypass tank 92, goes down to this line, okay, and flow through this flow meter FI92. It will show some reading and then go out and flow through this control valve and then goes up.
From this video, I believe you can identify which of the valves should be closed and which one should be open. To start your experiment, you have to press RCD, which is a record button at this PR91. This PR91 is a chat recorder, whereby the response of a system will be recorded here in the form of graph. Moving on to the next procedure, you have to access the value of PID setting, or known as PID value, which is the value of PV1, TI1 and TD1. This is the main screen of this PIC91 controller, whereby this is a secondary screen. To get this screen, you have to press Shift button and this button simultaneously. Once you get to this screen, you are able to adjust the value of PV1, TI1 and TD1. The definition of this value, PV1, TI1 and TD1, you will learn later. The next procedure, you have to set the value of your set point to be 18 psi here. And make sure you already press the RCD button again. And you have to transfer the mode of this controller to become auto mode by pressing A button. Once you press A button, this controller will do the job for you. This controller will compare between the value of PV and SB. The ultimate goal of this controller to bring PV1 value equal to SB value. This controller will send a signal to a control valve to further open or further close in order for the value of PV become the same as the value of SB. For the value of PV less than the value of SB, this controller will send a signal to control valve to further close. When the control valve is further closed, the value of MV is increased. When the control valve is further closed, the air cannot flowing out of the tank and the pressure will be increased. Same goes when you have the value of PV higher than the value of SB. The controller will send a signal to a control valve to further open in order to release the gas so that the pressure will be decreased. There are a set of PID value that you have to test in this experiment. Along with the PID setting, there are two types of tests that you have to apply to the system, and you have to observe the response of this controller setting. Here we have the same setting, which is PV1 equal to 70, TI1 equal to 40, and TD equal to 0, with a set point of 18, and once the process reaches steady state, you have to apply load step test. To apply this load step test, you have to refer to the next procedure. With the same setting also, you have to change the set point. These two types of tests is commonly used to evaluate the performance of controller. Once your system reaches steady state, you have to put the controller into manual mode, and you have to decrease the value of MV by 5 to 10% by pressing these two buttons. You also can choose to increase the value of MV. Once completed, you have to quickly switch back the controller into auto mode and observe the pressure response. This is called load step test, whereby you disturb a system to see whether this controller can bring the system back into set point, or known as good disturbance rejection. Once the system reaches steady state again, you can proceed to next procedure. But before that, I would like to explain theoretically what's going on when you apply this load step test. Theoretically, we have a process, we have input and output. From a very beginning, you learn about mass balance and energy balance. We're talking about a process. There are input and output to the process. In this case, this process represented by a control system. This control system have the element of controller, control valve, the process itself, and the transmitter. For this system, we are giving a set value as our input. Once the control in auto mode, this controller will give a signal to a control valve whether to further close or further open in order for the value of PV equal to the value of SB. This controller will react based on the value of setting, the value of PB, TI, and TD. This set of value will affect the performance of the controller. And you will see a response from this system. This is one of the example of response which is in this graph. Once you start a load step test, you are changing the controller to become a manual mode, to be in a manual mode, whereby you increase or decrease the value of MV. In this condition, you are giving this control valve input manually the value of MV. Then you have to change back into auto mode so that this controller will again do the job to bring PV equal to SB. The ultimate goal of the controller is to bring the PV equal to SB. This controller will compare the value of PV and SB based on the error, based on the value, based on the difference. This controller will send a signal to a control valve. And this transmitter will measure and give back the signal to the controller. This loop will continuously occur until the process reaches steady state. You will learn further about this loop in Chapter 8. When you have another type of step test, which is a set point test, whereby we're going to change the value of set point. In this case, the controller can remain in auto mode. You just have to press this button to increase the value of SD, or this button to decrease the value of SB. In condition of the controller in auto mode, and you just have to wait for it to respond. So, as compared to the previous one, you didn't do anything here, but you changed the value of set point here. When we change the value of set point from 18 to 9, we would like to observe the performance of this controller based on this setting, whether the performance is good or not. The performance of this controller, you will be learned. I will give you some knowledge later on. To evaluate the performance of a controller, the response has to be characterized by this parameter. You will learn about this later on in class. What is the definition of this parameter? In this procedure, you will need to observe your response, whether the response tends to oscillate outside the desired value. If it is inside, it is okay, but if the response tends to oscillate outside the desired control band, you should check. There are things that you have to do, which is you have to decrease the value of TI to 10 to 20 instead of 40. so that it will reduce the effect of integral of the controller, and it will slow down the process inlet so that the oscillation can be removed. But for this procedure, you will really need your response in terms of graph to set it. Without that, difficult for you to understand. And last but not least, to stop the experiment, you have to shut the MV91 so that there is no air supply into the system, and then you have to switch the control valve. You have to switch the controller to manual mode and reset the value of MV to 0% so that the control valve is fully open. All the gas, all the compressed air can be released from the tank, and you can shut down fully the system at the switch button. Okay, I think that's all about this experiment. If you have any question, you can direct message me, and I will be seeing you in a class later on. Okay, thank you.